So in this video, I'm going to go through Add Maths, Chapter 9, Section 2, and it's 3D Trigonometry. And before I do that, let me just give you some tips for answering 3D trig questions at this stage. Firstly, draw a diagram to summarize the information given, sometimes most of the information given. Sometimes it won't all fit in one diagram. You need to know that you will have to reduce each part of the question. So by that I mean question A, question B, question C to a triangle, or a quadrilateral, then a triangle. So each part of the question potentially can have you drawing a different shape with different information. Sometimes you can summarize all the information in one shape, sometimes you really can't. So it's not like the bearings questions. With 3D trigonometry, you often have to draw and imagine the question slightly differently. Not all the triangles will be right-angled, so you don't have to use SOHCAHTOA alone. You can use the sine rule, the cosine rule, trig area of a triangle as well. You also need to know that you need to write all your long answers down before writing them. So don't just round and only write your rounded figure. Don't just think it's going to be saved on your calculator because you might need something from part A for part D. So write all your long answers down or write them as surds. Never use rounded numbers in later calculations. You will lose accuracy and you will lose marks. The first question is pretty much a GCSE question, so you might want to pause the video, do it yourselves, and then just quickly fast forward and find the answers and check your work, but I will go through it. So you've got the wedge A, B, C, D, E, F, they're telling you the information, and you know that the angle BCD is 90 degrees, and it says find AC. Well, I always like to annotate the diagram if that's possible. Sometimes I'll draw my own diagram as well. So AC is the hypotenuse, and therefore it's 8 squared plus 6 squared. It gives me a nice, neat answer. It's 10 centimeters. Part 2 says find AD. And again, I'm going to draw that in from A to D. And you can see that I have a right-angled triangle, 10 centimeters and 2 centimeters. So AD is the square root of 10 squared plus 2 squared, and it gives you the square root of 104, or 2 root 26. Or you can use the long answer 10.19803903 centimeters, and of course I will round my final answer to 3 significant figures. Usually for lengths and distance it's 3 significant figures, and for angles it's 1 decimal place. And then question 2 says find the angle, and this symbol here means the angle. Find the angle DAC. So DAC is here. Ooh, there we are. So that means this is the opposite. This is the hypotenuse. This is the adjacent. So I've got the opposite and the adjacent. I do have the hypotenuse, but it's a long number, so I'm going to use opposite and adjacent, which means that I want to use tan. So TOA, and since I want the opposite, it means theta is tan minus 1, 2 divided by 10, which is 11.3099347 degrees, 11.3 degrees to 1 decimal place. And then question 4, they want you to find the angle DBC, and DBC is part of this, again, right-angled triangle with the opposite and the adjacent. So again, I'm using tan with 2 and 6. So theta is tan minus 1, opposite, which is 2, divided by adjacent, which is 6, and that's 18.434948882 degrees, which is 18.4 degrees to 1 decimal place. And the next question is straightforward as well, so again you might want to pause the video, do it yourself, and then quickly go through the answers. So the drawing shows a straight level road, AB 400 meters long, a vertical radio mast, XY stands some distance from the road, and the bottom of the mast X is on the same level as the road. The angle of elevation of Y from A is 30 degrees. Remember, angle of elevation is when I'm at the bottom from the horizontal looking up to something. So that's the angle of elevation. And the angle of depression is when I'm at the top looking down. Okay, and it says calculate the distance AX. So I want to find this one first. And this is a right-angled triangle. So AX B is a right-angled triangle, which means this is the opposite, this is the hypotenuse, because it's opposite the right angle, and this is the adjacent. I want to find the adjacent, and I have the hypotenuse, which means to find A to X. I am going to use cos. So K. And because I want to find the adjacent, it means adjacent A to X is cos 25 times 400. And that gives me 362.5231148, and it's meters. And to 3 significant figures, I'm going to round the 2 up, so 363 meters to 3 significant figures. So that's A to X. And then for part 2, it says find the height of the mast. That's the mast. So I'm trying to find Y to X, and again I've got a right-angled triangle. This is the opposite. This is the hypotenuse, which I don't have. This is the adjacent. So I want to use the ratio with O and A, so that is going to be tan. So to find XY, I want to use tan, TOA. And since I am trying to find the opposite, I'm going to do tan 30, because that's the angle, tan 30 times answer. It should still be in your calculator. So that is the answer. And it should give you 209.302879 meters, and to 3 significant figures, 209 meters. And finally, they want you to find the distance of X from the road. So if I take off all these annotations, the distance of X from the road is this one. And again, I have got a right-angled triangle. I do know what AX is because I found it out. So that's the opposite, and that's the hypotenuse. I want to find the opposite, and I have the hypotenuse, which means I can use the sine rule. So the distance XD, I'm using sine, and I want to find the opposite, so I need to do sine 25, and this time you have to round you have to write it all out. 362.5231148, because it's not saved on your calculator anymore. And that gives us 153.2088886 meters, which is 153 meters to 3 significant figures. Okay, so I'm moving on to a couple of questions from exercise 9.2, and it gets a little bit harder. So A, B, and C are points on a horizontal plane. If I have A, B, and C, that means there is a general triangle that I can draw. And I would advise you to draw A, B, and C, and then fit the measurements in, rather than the bearings questions, where I would ask you to kind of be a bit more exact. From C, how do I get to B? Am I going this way or that way? This time, sketch it out first, because more often than not, you will have to draw a different diagram for each part of the question. So do a general sketch first. It's a sketch. Draw your triangle. A, B, and C are 3 points. 3 points means a triangle, and then go from there. So let's do that. I've got A, B, and C. And it says, from C, so it's A, the bearing of A from C. So from C is your starting point. So here's the north line, bearings, north line. From C to A, that means this is 210 degrees. The bearing of B, again, from C. So from C to B, so just this bit is 120. So that's 120 degrees. And then it says the bearing of B from A. So from A, here's my north line. So from A to B is 75. So all of that, 75 degrees. So let's do some working out. If I know all of this is 210, it means I can work out what this is, because that's angles around a point. So 360 minus 210 is 150 degrees. So I know that this is 150 degrees. If I know that all of that is 210, and I know that just this bit is 120, I can find the bit inside the triangle. So I can find this. So I've got 210 minus 120 is 90 degrees. So let's rethink the sketch. That is now your right angle, okay? Which means this is a hypotenuse, it's important. And I am going to now remove this, I don't need it anymore, and just say 120 degrees. Now remember, co-interior angles add up to 180, and those north lines are parallel lines. So if this is 150, I can find out what this is. So because they're co-interior angles, and they add up to 180, so 180 minus 150 is 30 degrees. I'm going to say co-interior angles inside the north lines, or between the north lines. Let's put between. So that means this is 30. If I know that this is 30, I can find out this angle there inside the triangle, because I know that all of this is 75. So 75 minus 30 gives us 45 degrees. So if I remove that, I don't need this now. This is 45 degrees. And you know, technically I can even find this one out as well, if I need to. So I've done a rough sketch, certainly for most things I need. It says from the angle of elevation to the top of a vertical tower at sea. There's a tower at sea, but we're going to ignore that for now. Okay, so there's another tower at sea, and I'm not going to put any more on this diagram. It's already quite busy. Let's look at the first question. It says, find the distance B to C. Okay, B to C is part of that very simple triangle that we have. And I know that where C is a right angle. So I'm going to draw my information a little bit differently. A, B, C. C is the right angle. And it also says that A to C, so at the top it says A to C is 75 meters. I want to find B to C, and I also know that this is 45 degrees. So I want to find B to C. This is the opposite, this is the adjacent, which means that I'm going to use tan. So B to C, I'm using tan. B to C is the opposite. So that means tan 45 times 75, which gives us 75 meters, because tan 45 is 1. So I now have B to C, and B to C is 75 meters. And then it says I want the height of the tower. So I actually need to do a different sketch, and it needs to encompass this bit of information separately. There's A to C, then there is a tower, which makes your 90 degrees, and there is your C. So I've got A to C, which is 75 meters. I already know that. I've got a tower, which is 90 degrees going up from C, and it tells me that the angle of elevation from A looking at the tower is 42 degrees. And so I've got the opposite, and I've got the adjacent again. So I want tan. So I'm going to say T to C is tan 42 times 75. And you put that into your calculator, and it gives you 67.5300332 meters, which is 67.5 meters to 3 significant figures. And then the final part says the angle of elevation of T from B. So I now really need a different diagram that can connect A, B, and C and T together. A, B, and C are still points on a horizontal plane. T is different. T is a tower, so it's going up. There's a kind of a 3D aspect to it. So let's have a go at this. I know that C is a right angle. I've got A and B, and notice that A to C is 75, and we did find B to C, and that was 75 meters as well. So it's an isosceles right-angled triangle, and then from C I get the tower T, and I know that the angle of elevation here is 42 degrees. What do you think it's going to be there? Because that's what they want. They want the angle of elevation of T from B, which is this one. Well, they both have 75 meters. They both have T, which means that the hypotenuse, or the third side, it's not a right angle triangle, the third side is also the same. So these two triangles are congruent. They're identical triangles, which means their angles are also going to be identical. Therefore, TBC, the angle, equals TAC equals 42 degrees. So the angle of elevation of T from B is 42 degrees. And again, that's what I was saying about sometimes having to reimagine the diagram for each question. And this is the last example I want to go through, and it's from exercise 9.2, and it's question 6. And it says, the waste paper basket shown in the diagram has a top ABCD that is a square of side 30 centimeters. So 30 centimeters, 30 centimeters. And the base PQRS, that is a square of side 20 centimeters. So 20 centimeters and 20 centimeters. The line joining the centers of the top and the base. So note, that's the top, the whole thing is the top. A, B, C, D. And the base is that's the base, the whole thing. So be very clear what they're talking about. They're not talking about lines, they're talking about the whole square. Okay, the top and the base. The line joining the centers of the top and the base is perpendicular. Well, to both, and is 40 centimeters long. Where is the center of AC? Or where is the center of the top and the base? Well, the center is about here. It kind of lies on the diagonal. It's the intersection of the diagonals. And where's the center of, that's the center of the top, that's the center of the base. Again, it's the intersection of the diagonals. So that line there, let's put one there, is perpendicular and is 40 centimeters. And that will come in handy, but just reimagining the question, that's the general diagram. Right, let's look at each question separately. The length of PR, so I want the length of PR, lovely. So I can see this is a square, they told us it's a square with 20 and 20, so PR is, the diagonal is the hypotenuse, so it's the square root of 20 squared plus 20 squared. And that's going to give us root 800 or 20 root 2, or you can write the whole answer, and I'm going to round it 28.3 centimeters to 3 significant figures. And then they want the length of AC. And again, AC is the diagonal of the bigger square at the top. It's the hypotenuse. So it's the square root of 30 squared plus 30 squared. And it's root 1800 or 30 root 2. Or you can write the full answer, and I'm going to round it to 42.4 centimeters to 3 significant figures. And then comes the last question, and it says, I want the length of AP. Let's have a look at AP. AP is this. And I hope you can see a shape that is ACPR, and I've already found the AC and PR, and I know what the perpendicular is. And this is a parallelogram, basically. So let's look at that one. I've got AC is the parallelogram. Nope, it's a trapezium. It's a trapezium. There we go. So we've got AC and PR, and we know that the distance between them is 40, and I can actually put the distance here. That's 40, and here, that's 40. And I know what the top is as well. So I'm going to label the whole thing. A to C is 1,800, the root of 1,800. P to R is the root 800. And those two distances I want to find as well. And I find those two distances by taking away root 800 from root 1,800 and dividing by 2, because they will be equal. So this distance is found in this way. Root 1,800 minus root 800 divided by 2. And it gives us 5 root 2 centimeters. And I'm not rounding, I'm leaving it as such. So I want to find AP, and this is a right angled triangle. So I'm going to use Pythagoras theorem. AP is the square root of 5 root 2 squared. Put it in brackets, put the square outside of the bracket, plus 40 squared, which gives us 5 root 66, which is 40.62019,202 centimeters, which is 40.6 centimeters to 3 significant figure. So the main trick in this question is to recognize where these centers are, and to note that this makes a trapezium. So to note that since they've asked you to find AC and P to R, that they are linked and they make their own quadrilateral ACPR.